Fantastic. I'm Stephen Saperstone. My colleague and co-author Max Saperstone is also online with us. And today I'm going to give you a rundown on this interacting with ordinary ODEs that I've developed over a number of years now. So kind of briefly, I'm going to start off with some history, talk about the old software that I used to write interaction with ODEs, talk about the interactive components, talk about how I've used links all over the place, talk about a lot of the challenges I've had, especially with the interactive components, and then also matters of publishing. So with regard to some of the history, let me give you some background here. I started out probably about over 20 years ago to create a set of online lectures for my undergraduate ODE class. And at the time, I'd been using software called Scientific Workplace to develop exams and, handouts and stuff like that. And actually, Scientific Workplace was a WYSIWYG kind of software. So what you see is what you get. You have to develop a style sheet for it, but once you create the style sheet, you get exactly what you're going to see on the screen. And turns out that this software company McKicken Software went out of business about 3 or 4 years ago. But at least at the time I was using it, it worked fine for me. And I had seen, during those years, I had seen lots of examples of dynamic interaction in the Wolfram Demonstrations project. And I was inspired to modify and to create some of my own notebooks and embed them in my digital textbook. I wouldn't call it a digital textbook then, it was my online digital notes. And also at the time, Wolfram, the developers of Mathematica, had developed a Java plugin called Wolfram Playwright. And you could take a notebook and literally embed it in a web page and get very nice results. And I'm just going to give you an example of that now, which I have here, hopefully. Here. So this was the first one that I wrote quite a while ago. It's just a slope field. And you've seen examples of slope fields done by a lot of people. In fact, I think on the first day's talk, Tim Lucas showed off his slope field for handheld devices. And, this was patterned after D field that John Polking wrote way back then. And this has a nice feel for it. All you got to do is click on any place you want on the slope field, and you get a solution through that point. And it follows the flow. You can also change field, and I'm going to delete the solution because they don't follow the field that I just had. And now I'll put some more in here like this. So this is very simple. You can also enter values keyboard entry. So we'll just demonstrate that very briefly. Turns out just very fortunate it overlapped the other one. So let me go back to the slide. The problem with this plugin was that they were declared they lost their status in about 6 or 7 years, maybe a little bit longer, 8 years ago. Browsers found that they were insecure. They allowed for problems with people in security. So they were banned, and they're not on the browsers. And there may be a browser around that allows it, but it's not in one of the major ones. And that's what we need to use in here. So that meant I had to figure out a different way to embed my interacts, which I call them, in the web pages. So here's a typical interact embedded in a web page. What it does is that it illustrates the integral definition for a nonlinear scalar differential equation, that's what I call an explosive growth equation. has a single parameter R. I picked initial value, and here's the result of changing the parameter R, which is basically the growth rate. And you see, as you move the slider back and forth along here, it'll move the vertical asymptote, which changes the length of the interval of definition, which is what I was trying to show off here. The problem with this new version of the Interacts is that they're not computed on your desktop like the Wolfram Player did. What happens here is that I've had to take all my notebooks, move them up to the Wolfram Cloud, export what's called a cloud embed file down to my desktop, and put that in the code for the web page. And that takes time for the information to go when I start to move the slider up to the cloud and back. And some very simple Interacts, it works quickly, and others not so quickly. I'll give you another example. So this is it's a model of the Tacoma-Narrow Bridge problem, which when it was first analyzed back in 1940, it was thought to be due to resonance, but a number of mathematicians in the interim have come up with a different model for it, that it was due to a wholly different situation. So here's what happens when we go this way. None of this is smooth. It's very herky-jerky. And so all the intermediate steps kind of disappear as this thing works along. So this is a major problem with dealing with the cloud. And we'll talk about possible solutions to this issue, as we go along. I've also, in order to get rid of some of the herky-jerkiness, what I've done is to make a couple of videos. So for another model, which you've all seen for predator-prey. So this is a simple model of a pair of nonlinear first-order differential equations. Predators and preys are depicted on the left-hand side, and the phase plane on the right-hand side. And this proceeds, again, in this slightly jerky fashion, but that's the best I could do on this one. And then for a different case, so here, so this is the flow associated with the logistic equation. And you have the solutions on the left side of this graph, starting out and approaching either equilibrium or going away from equilibrium, and then the projection down onto the phase line on the right. And now I'll try and give you some more examples. So this is representation of an implicit solution to a differential equation. The solution you see down here at the bottom of the plot. And as I change, the solution is differential equation is right here, and it's an implicit solution. And there's a constant of integration. If you change that constant of integration, it'll certainly affect the plot that you see over here. Again, one of the issues with Wolfram Cloud is that if I have to leave something sitting here for about a couple of minutes, it'll disappear and I have to refresh the page all over again. And that's just, again, another issue that would love to be resolved, but perhaps a different way of creating these interacts. So one of the other features I've created here is note links, or ways of hiding some detail when the student or reader is trying to understand, what's going on. So I'm going to go into a different page here. So in a very different differential equation. I wrote down the solution. It's not difficult to do. It turns out to be a separable first order equation. But students for the first time are not necessarily very fluent in dealing with these things. So if you try to do it on your own and you get stuck, all you got to do is go down here and follow the computations for the solution, and you're good. I think I have a few others up here. Maybe the same thing. There's another one. So here's the differential equation. Its implicit solution is written right over here. And I created a direct for this one. Still loading. I can see the little blue bar sliding across the top here. It's not. I'll just move on. So I've used a lot of links. So when we're solving an equation or looking at a theorem and trying to understand the definition or following examples, there are a lot of links listed, and you can just follow these links to get back to what. So here's a lecture on Euler's method. And again, you have links to follow Euler's demo. This one here, again, it's not responding. I'm sorry about that. These big blanks are where the cloud has decided to disappear. Here's another one. Here's a calculation for a particular differential equation. Here's a logistic equation. The idea is to explain how to solve this. Here's most of the detail, but you're going to have to do this, evaluate this integral up here, which requires usually integration by parts. The students, again, that have don't remember how to do this or haven't done it in a long time. Here's the details if you want to work your way through it. Again, down below, it's another model. Free fall, or not necessarily free. There's the one I've used here has this resistance, the drag force. And again, for students who need to review some of the physics of this Newton's second law, there's a link to go with that. And then discussions of the various parameters in here. And then again, the solution to this differential equation, which is kind of complicated. It goes through quite a few steps, but at least there, in case you get frustrated and try to do it on your own. Anyway, the idea is to be able to move around non-linearly in the text and not be weighted on going from, in a linear order. So that's kind of what I mean by layer explanation from the big picture down to details. And you've seen examples of these other issues. There are issues and challenges mathematically. First of all, aside from what you see here, you have to use Mathematica syntax in order to do an equation. I'll just give you another example here. So if I wanted to just put in sine x, so you have to use square brackets, you have to use the capital S in sine. Those are mathematical requirements. And so here's what you get when you do this one. If I were to change it a little bit, put in sine of tx, I have to leave a space and put an asterisk multiplication. Again, this one. So that's another, as I say, that's another issue with Mathematica. Not all Mathematica commands work in the interacts. For example, some of the mouse commands won't work on some of them. There's the latency, which I've been talking about. Also, give you a little back up a little bit in the history. This interactive with ordinary differential equations was published by the AMS back in about four or 5 years ago. And because I was using Mathematica, Wolfram required AMS to pay royalties. And after a while, AMS decided they were paying too much royalties and they dropped it. But nonetheless, that's another issue. And finally, there are other alternatives. I never investigated Maple, but I think JavaScript and maybe Python, you could write this code for this. But of course, doing it in these other languages is going to take a lot more work than it was to do in Mathematica. Finally, back about a dozen years ago, I went to one of the JMM meetings to speak with publishers about publishing this in a different form. And they all said, come back in about 10 years because you're way ahead of the curve here. We're not interested in it now. So today, though, there are a couple of publishers that publish interactive digital books. Top Hat was one of them. ODEs is another one. I did investigate Top Hat some years ago, but they decided that it was not for them. So I'll be glad to stop and hear any questions from any of you at this point.